Here is a single row of squares. Each square is either black or white. One simple rule colors the row below it. Do that again, and a pattern grows downward. No randomness, yet you cannot predict it. You might picture a whole grid of cells changing. But this is only a single row, with one rule. Each new row depends only on the row above. From a single black square, whole worlds appear. How can one rule do so much? Here is the plan for this one rule. First, one row and one simple rule. Each cell looks at 3 cells above it. Second, just 256 rules. 8 cases, each one on or off. Third, Rule 90 draws a neat fractal. Orderly, and easy to predict. Fourth, Rule 30 looks totally random. So wild it made real random numbers. Finally, Rule 110 can compute anything. The simplest rule that is a computer. Now let's see the one rule in action. Look at any cell and its 2 neighbors. Those 3 cells make a little pattern. The rule says what color goes below them. 8 patterns, 8 answers, and that is the whole rule. Start with one black square in an empty row. Apply the rule to get the next row. Repeat, stacking each new row below. The rows pile up into a tall triangle. The whole picture comes from that tiny rule. Now let's count how many rules exist. There are 8 possible 3-cell patterns. For each, the answer is black or white. That gives 2 to the 8th, 256. So every rule has a number, like Rule 30. Most of these rules are frankly boring. Some fill the screen, some die out fast. Some just make simple repeating stripes. But a few rules do something remarkable. 3 numbers are about to surprise us. Time for the first surprising rule. Rule 90 colors a cell from its 2 neighbors. From one square, it draws nested triangles. This shape is the famous Sierpinski triangle. It is complex, yet completely orderly. Here every smaller triangle copies the whole. You could skip ahead and know any row. The pattern hides no real surprises. It is order dressed up as complexity. Now watch what a tiny change does. And finally, the strangest rule of all. Rule 30 starts from one black square too. But its pattern looks completely scrambled. There is no repeat and no clear order. It is random, with no randomness inside. The rule is fixed, and nothing is left to chance. Yet the middle column looks random even to careful tests. For years it generated random numbers in real software. Determined to the last cell, but unpredictable. Certainty and chaos, from a single rule. Now meet the most powerful rule of all. Rule 110 sits between order and chaos. It makes gliding shapes that move and collide. With the right start, those shapes carry signals. Arrange them well, and the row computes. In fact, Rule 110 can compute anything. Anything your laptop can do, it can do too. This single rule is a complete computer. One line of cells, running the simplest rule. A computer hiding in one rule. So why can't we just predict these patterns? For rules like this, there is no shortcut. To know row a million, you run a million rows. The fastest way to the answer is to live it. That wall has a name, computational irreducibility. So what does one little rule leave us? The same setup gave order, randomness, and a computer. Complexity was never hiding in complicated rules. It was waiting inside the very simplest ones. The simplest rule already holds everything.